Hi and welcome. In this video I want to talk to you a little bit about something called bit depth. Now what exactly is bit depth? Well, let's examine it in terms of something that we all can relate to, and that's money. Now here we've got an image that's got a bit depth of 1 and we've got a pound. Now in this image we've got a bit depth of 4. Now which one would you rather have? I know which one I'd rather have. I'd rather have £4 rather than £1. Well, in our images we're not talking about money, we're talking about colours. The higher the bit depth, the more colours that our images can contain. And so the more vibrant and the more interesting that our images will look. Okay, well, let's learn a bit more about it, and we're going to do that right now. My name's Ken Fisher, and this is LiveLink Training. Okay, as I said in the introduction, a common term used in photography is bit depth, particularly when discussing RAW files. Now JPEGs are described as 8-bit, while RAW files are commonly referred to as 12, 14 or 16-bit. But what does this mean practically? What actually is bit depth? Now for each pixel in your image, the tonal value or brightness of the scene you are photographing is recorded along with the colour. Now computers work in binary, so they can store information in zeros and ones, and that's it. And bit depth refers to how many digits we have to store the tonal information for each pixel. So in this example we've got a 1-bit computer, a 1-bit image. And now what this computer can do, it can only see 1 digit. So it can only have 2 possible courses. It's a bit like a light switch. It can either be on or it can be off. So it can have a 0 or a 1. So there's only 2 options. So if you can imagine this as being like a cupboard, we can potentially now store 2 values. We can say, well, we'll assign 0 to be black and we'll assign 1 to be white. So we end up with a 2-bit image. Here we can store black and we can store white. Now that's going to result in a particularly not inspiring image, but it's basically just a 1-bit image. It can only store black and white, so we have no greys, we have nothing in between, no midtones. Okay, let's move on now to 2-bit. Now in 2 bits we've got 2 bits. Here we've got a 0 and a 0. Now if we look at this, we can store now 4 different options. We could have this as 0 0 or a 0 1 or a 1 0 or a 1 and a 1. Now this means if we go back to us cupboards, we need 4 cupboards. And we can say 0 0 is white, 0 1 is black. 1 0 we'll call that dark grey, and a 1 1 we'll call that light grey. And you can see here we've got black, we've got a dark grey, we've got a light grey, and we've got white. Still quite thick banding on this, so a 2-bit image isn't going to be particularly interesting either. But we're still going to be getting closer. We've got some greys in this now. We've got dark grey, light grey, we've got black, and we've got white. Now I'm not going to bore you all by going all the way through with the 3-bit, 4-bit, 5-bit. I think you can see where we're going with this. Let's stop at the 8-bit, which is the important one, which is what our JPEG images are. Now using the same mathematics, we come to the 8-bit image. It ends up with 256 potential basically places we can store colours and tones. And because we've got 1 2 3 4 5 6 7 8, we've got an 8-bit image, we've now got 256 different options. We've got 7 zeros, 1 right through to 1 1 1 1 1 1 1. Now what this gives us is 256 potential boxes down, 8 ones across, so we end up with 256 different options of tone that we can save. Now you can see this now that we've still got all these little bands that we had before, but now they're so small we can't see them. And they all grade together now to form like a continuous tone going from black through right to white. And this is the kind of image we get. Here we've now got what we class as our JPEG image, which is a continuous tone image. And we've got the darks, we've got the midtones, we've got the highlights, we've got it all. Now let's take a jump to 16-bit. Now 16-bit, I'm not going to bore you with the maths of it, but basically we've got a 16-digit number which we can go from 15 digits and a 1 to 1111 16 times. So basically we've got 16 digits, and that gives us over 4,000 potential tonal values we can store, and that's per channel. Now to put this in perspective a little bit, if you think about the 8-bit image, we can store 256. So basically with 3 channels we can store 256 times 256 times 256, which is something like 16 million colours. With a higher bit depth image, like a RAW file, we've got 4,000. So per channel, so 4,000 times 4,000, 4,000 is, well, it's a lot. And I'd need my calculator. It's 25 gazillion. So you can see we've a lot more stuff in a 16-bit image than we have in an 8-bit image. Now 16 million might seem like a lot, but it isn't really. And with heavy editing, you could see colour banding and pixelation in your photograph. Now your high bit depth photo with billions of potential colours will hold up much better. Now the downside to high bit depth is larger image files. As a comparison, a 16-bit image will be at least twice as big as an 8-bit image. But with large memory cards available and cheap as chips hard drives, it's the way to go. Now, how's this going to work in practice for us? Well, let's have a look at a practical example. Okay, now let's look at an example. I've got 2 images here. One's called Barbadian Home 8-bit and the other one is called Barbadian Home 16-bit. And viewing at this, they look more or less the same. So what I'm going to do is a little bit of a destructive edit. Now this is something that you would never do in practice, but when you're editing an image, you could get to the sum of your edits could end up being just as bad. And I'll show you what I mean. So I'm going to go to Image and Adjustments and Levels. And you can see here I've got a decent histogram. But what I'm going to do now with my output levels, I'm going to throw away a lot of those tonal values. So I'm going to type 130 at the dark end, and I'm going to do 136 at the light end. And what I'm doing is now I'm throwing away all the tonal values from black right through to 130. I'm also throwing away everything from pure white down to 136. And you can see the image itself, it's turned a bit grey because that's all I've got. So if I click OK, I end up with a grey image. Now if I just go and show you the histogram on that again, I'll just do levels again. You can see now that this is all I've got left. I've got 6 tonal values right in the middle, which is mid-grey. Now you can see a little bit of the image that's just showing through. I've got a little bit left. So now what I want to do is try and reverse that by stretching out the pixels that we've got left. And I'm going to do that with the input levels. So now here I'm going to type 130 and we're going to use 136. And what this will do is stretch out the tonal values that are left. And if I click OK now, you'll see that this is what I've got left in my image. Now again, I'll show you the histogram. We'll go to Image Adjustments and Levels. And you can see now that this is all I've got left in my image. I've just got some spikes that's left because I've dragged the image tone so far that basically it's just like a piece of elastic. And what's happened is I've broke it and I've got gaps in between. And that's what we see here. This is posterization and banding, where we've just got a big clump of colour at the top because we've thrown away everything. We haven't now in this 8-bit image got enough boxes left to store all the colours in. So if I click OK on that, you can see that it looks a pretty poor image that's left. Okay, let's contrast that with the same image, but we've got the Barbadian Home 16-bit. Now you can see down here, I'll just show you, if we go back to the 8-bit image, that the document size down here is like 18 megabytes. On my 16-bit one, I've got a phenomenal amount more information. I've got 36 megabytes as a file size. So let's do the same adjustments. So I'll go to Image and Adjustments and Levels again. And I'll do the same thing on my output levels. I'll put 130. And in the input levels, I'll put 136. And then click OK. And of course, it's gone grey again, just like the last time. But now, if I do the reverse, if I go to Image and Adjustments and Levels again, and you can see I've still got this spike in the middle, but this is a relative scale. So now my 0 to 255 means really 0 to 4000. So I've got this spike in the middle again. So let's expand that again. We'll stretch that out by putting 130 and we'll use 136 again. And this stretches out the tones that's left. Now you'll see it looks pretty banded again. That's because it won't render out until I press OK. So when I do press OK, bing! You see now we've got a lovely image left with lots of tonal gradations in it. And if I go and show you the histogram, Image and Adjustments and Levels, you'll see we've got a nice smooth histogram. A couple of little blips here and there, but basically I've got a full tonal range left after I've made a really destructive edit. Now here you can see the difference between the two. That's my 8-bit showing posterization, and that's my 16-bit, where I've done the same edit, but I've still got a lovely image left. And this is due to the fact that at 16-bit we've so much more stuff. And even if we really throw quite a bit of it away being destructive, we've still got masses of it left. In the 8-bit image we haven't. And that is one of the great advantages of shooting and processing at 16-bit. Well, Photoshoppers, that's the ins and outs of bit depth. I do hope you got something out of that. If you did, please give me a thumbs up or leave me a comment under the video. And please click that subscribe button and join my Photoshop learning community. I'll see you in the next video. Bye for now.